The cosmos hides more secrets than we have yet uncovered. We are about to journey through 30 of the most baffling space mysteries that have no scientific explanation. From a signal so strange an astronomer scrawled "wow" on the data to a galaxy that seems to be missing its ghostly anchor. This is the universe's greatest unsolved case file, a tour that will challenge your understanding of reality itself. By the end, you will know the most profound puzzles that keep astronomers awake at night. We will explore a star that dims in impossible ways and a cosmic force pushing the universe apart. What single cosmic mystery makes you question everything you thought was true? On a quiet August evening in 1977, a radio telescope known as the Big Ear was silently scanning the sky. It was a routine survey, one of countless nights spent listening to the cosmic static. Then, for exactly 72 seconds, everything changed. A signal burst through the noise, so intense and so peculiar that it defied all natural explanation. When astronomer Jerry Amon reviewed the data printout days later, he was so stunned he circled the string of letters and numbers in red pen and wrote one word beside it: "Wow." That single word named the most tantalizing mystery in the search for cosmic company. The "wow" signal was not random noise. It was a narrowband radio blast concentrated on a specific frequency that hydrogen, the most common element in the universe, naturally emits. This is significant because scientists have long suggested that frequency would be a logical channel for any civilization trying to announce its presence. The signal was also incredibly powerful, leaping to 30 times the volume of the background cosmic hiss before vanishing completely. For 72 seconds, the Big Ear telescope, which was fixed to the Earth, had the signal in its sights as the rotation of our planet swept its field of view across that precise point in the constellation Sagittarius. And then it was gone, the signal never repeated. Despite decades of dedicated searches targeting that same patch of sky, the silence has been absolute. Every conceivable natural cause has been examined and discarded. It could not have been a passing satellite or aircraft, as those used different frequencies. It was not a random stellar event which would produce a broad spectrum of radio waves, not this clean, artificial-seeming spike. The signal appeared to come from deep space, a brief, brilliant shout into the cosmic dark. To this day, the "wow" signal stands alone, the one event that perfectly matches what we would expect an intelligent message from the stars to look like. It is our best candidate, a ghost in the machine that continues to haunt our imagination, a single, unanswered question mark hanging in the void. From a fleeting signal lost to silence, we turn to a ghost that permeates the cosmos. This is not a momentary event but a constant, unseen presence. Across the universe, galaxies are spinning too fast, their outer stars whirling at speeds that should fling them into the void. Yet they remain, held in place by the gravitational grip of something we cannot see. This is the enigma of dark matter, a shadowy substance that makes up roughly 27% of everything that exists, yet has never been directly observed. We know it is there only by the ghostly fingerprints it leaves behind. Its gravity acts like an invisible scaffold, shaping the very structure of the cosmos. Without it, galaxies would fly apart, and the universe as we know it would not exist. The evidence is everywhere. We see it in the way immense clusters of galaxies bend light from objects behind them, a phenomenon called gravitational lensing, which reveals far more mass than the visible stars and gas can account for. We feel its presence in the precise patterns of the cosmic microwave background, the ancient afterglow of the Big Bang. So what could this mysterious stuff be? Scientists have proposed a zoo of theoretical particles. The leading candidates are known as WIMP, or weakly interacting massive particles. These hypothetical entities would be heavy and rarely interact with normal matter, passing through our planet and even our bodies as if we were not even there. Another promising idea involves particles called actions, which would be incredibly light and wave-like. For decades, physicists have built exquisitely sensitive detectors deep underground, shielded from cosmic rays, hoping to catch the faintest bump or flash from a single dark matter particle colliding with ordinary atoms. So far, every one of these experiments has come up empty. We are surrounded by an ocean of this invisible material, swimming through it every second, yet it remains utterly silent and undetectable. This makes dark matter one of the most profound and humbling puzzles in all of science, a fundamental component of reality that we can only perceive by its shadow. But if dark matter is the invisible scaffold holding the cosmos together, what force is actively tearing it apart? The answer is an enigma even more baffling, a pressure that makes up a staggering 68% of the entire universe. This is dark energy, and its discovery shattered one of the most fundamental assumptions in cosmology. For most of the 20th century, scientists believed the universe's expansion, born from the Big Bang, was gradually slowing down. The collective gravity of all the matter, both seen and unseen, was expected to act as a cosmic brake, pulling everything back together. Then, in 1998, two independent teams of astronomers made a shocking observation. By studying distant stellar explosions known as Type I, a supernova, which act as standard candles for measuring cosmic distances, they found the universe was not slowing its expansion at all. It was speeding up. The most distant galaxies were flying away from us faster than anyone had predicted. It was as if you tossed a ball into the air, only to watch it shoot away from you into the sky at an ever-increasing velocity. This revelation was so profound it earned the researchers the Nobel Prize. The culprit, this dark energy, behaves like an anti-gravity force. Its repulsive gravity actively works against the attractive pull of both normal matter and dark matter, pushing the fabric of space itself apart. So what exactly is it? The truth is, we have no idea. One leading theory suggests it is a property of empty space itself. According to quantum physics, a vacuum is not truly empty, but seethes with virtual particles popping in and out of existence. This could endow space with an intrinsic, repulsive energy that grows stronger as the universe expands and creates more space. Another possibility is that dark energy is a new, dynamic energy field permeating the cosmos, one that has changed in strength over the lifetime of the universe. The most radical idea of all is that our understanding of gravity itself is incomplete, and Einstein's theory of general relativity, while brilliant, breaks down on the largest imaginable scales. The true nature of dark energy remains one of the most profound questions in physics. It is the dominant component of our reality, an unseen engine driving the ultimate fate of everything, and we are only just beginning to grasp its mystery. If dark energy is the force tearing the cosmos apart, then the profound silence from the stars suggests a universe that is not just expanding, but perhaps profoundly empty of company. This brings us to a question first posed over lunch more than 70 years ago. The brilliant physicist Enrico Fermi, amidst a casual conversation about flying saucers and the potential for interstellar travel, looked around and asked a devastatingly simple question. Where is everybody? The universe is ancient, nearly 14 billion years old, and vast beyond comprehension, filled with hundreds of billions of galaxies, each with hundreds of billions of stars. Statistically, there should be an abundance of Earth-like worlds, planets where the chemistry of life could have begun. Given these numbers and the immense head start other worlds would have had, the galaxy should be teeming with civilizations. Their ships, or at the very least their radio signals, should be everywhere. Yet when we listen, we hear only a cosmic quiet, a great silence that stands in stark contradiction to our most optimistic calculations. This is the Fermi Paradox, the unsettling gap between the high probability of alien intelligence and the complete absence of any observable evidence for it. So what could explain this eerie quiet? One chilling possibility is the concept of the Great Filter. This theory suggests that there exists some kind of universal barrier, a developmental step that is exceptionally difficult for life to overcome. This filter could lie in our past. Perhaps the spontaneous origin of life from non-living chemistry is so astronomically unlikely that it has only happened once here. Or maybe the filter is ahead of us. It could be that the path of technological advancement inevitably leads to self-destruction, perhaps through nuclear war, engineered plagues, or a runaway artificial intelligence. In this scenario, the silence is a grave warning, a sign that no civilization survives its own technological adolescence. Other solutions are less ominous but equally strange. Perhaps intelligent life is common, but it evolves into forms so alien that we simply do not recognize its signals or its artifacts. Their technology might be based on principles of physics we have not yet discovered, operating in ways that are invisible to our current methods of detection. Another thought is that spacefaring civilizations eventually turn inward, creating immersive virtual realities that are far more compelling than exploring the barren physical universe. Or they could be out there but have chosen a deliberate silence, a cosmic quarantine, watching us from a distance to see if we can grow up without interference. The Fermi Paradox holds up a mirror to humanity, forcing us to confront our own place in the cosmos. Are we the first, the last, or simply the only ones to have made it this far? The answer remains hidden in the quiet between the stars. While the Fermi Paradox paints a picture of a silent cosmos, one star in our galaxy seems to be screaming with anomalies. KIC 8462852, more famously known as Tabby's star, behaves like no other. Located over 1,000 light-years away in the constellation Cygnus, it was the Kepler Space Telescope that first spotted its impossible flickering. Most planets cause a star's light to dip by less than 1% in a regular, predictable rhythm. But Tabby's star is different. It experiences sudden, catastrophic drops in brightness, some as deep as 22%. That is not a planet. That is the equivalent of dozens of Jupiter-sized objects passing in front of the star at once, blotting out a colossal amount of its light. What makes it even stranger is the pattern, or rather, the complete lack of one. The dimming events are erratic and asymmetrical with no discernible schedule. They can last for days or just a few hours, and the star's overall brightness has even been observed to slowly fade over years. This is not the clean, repeating signature of an orbiting world. It is the light curve of chaos. Astronomers scrambled for a natural explanation. The first and most popular idea was a giant swarm of comets, thousands of them, dragged in from the outer system by a passing star's gravity. This cloud of icy debris, the theory went, could be responsible for the irregular blocking of the star's light. But the math never quite added up. To cause such extreme dimming, the number of comets required would be astronomically high, far beyond anything we see in our own solar system. More recent studies point to very fine, opaque dust orbiting the star. Dust can clump in strange ways and is excellent at blocking light, yet even this theory struggles. The dust would need to be replenished constantly, as the intense stellar radiation should push it away over time. The star's long-term fading remains a puzzle that circumstellar dust does not fully solve. With every conventional answer hitting a wall, a more speculative idea emerged, one straight from the pages of science fiction. Could we be witnessing the construction of an alien megastructure? The concept, known as a Dyson sphere, involves an advanced civilization building a vast swarm of energy collecting panels around their star to harness its total power output. Such a structure, under construction and not yet complete, would indeed cause the kind of bizarre, irregular, and deep dimming that we observe. It is a breathtaking thought. But scientists are rightfully skeptical. Extraordinary claims require extraordinary evidence, and so far, follow-up observations have found no telltale radio signals or technosignatures emanating from that region. The alien megastructure remains the least likely, yet most captivating hypothesis on the table. The truth is, after years of intense scrutiny from the world's most powerful telescopes, Tabby's star continues to defy a definitive explanation. It is a cosmic Rorschach test, a celestial reminder that even when we look directly at the universe, we might not fully understand what we are seeing. While we watch the skies for grand cosmic mysteries, some of the most puzzling clues have been found much closer to home, hiding in the silent flight of our own robotic ambassadors. The Pioneer 10 and 11 probes, after their triumphant tours of the outer planets, were coasting into the abyss beyond our solar system. For decades, scientists meticulously tracked their trajectories, only to discover something was subtly wrong. Both spacecraft were experiencing a tiny, unexplained acceleration, a constant tug back towards the Sun. This was the Pioneer anomaly, a deviation so small it amounted to less than a billionth of the gravity we feel on Earth, but for the laws of physics as we know them, it was a glaring inconsistency. The detective work began. For years, this tiny pull was a thorn in the side of orbital mechanics. Could it be the gravitational pull of an unknown, unseen planet? Was it the drag from dark matter concentrated in our solar system? Perhaps it was an error in our understanding of gravity itself, a sign that Einstein's theory needed a slight modification at the very edges of our cosmic neighborhood. Teams of researchers spent years analyzing every possible cause, from the influence of the solar wind to potential software glitches in how the tracking data was processed. The most mundane explanation, and the one that eventually gained the most acceptance, involved simple heat. The Pioneer spacecraft were powered by radioisotope thermoelectric generators. These devices create electricity from the natural decay of radioactive plutonium, and in the process, they generate a significant amount of heat. The theory suggested that this heat was not radiating away from the spacecraft uniformly. Instead, it was being emitted slightly more in one direction than the others. Picture a car on a cold day with the heater blowing warm air out the front windshield. That escaping heat exerts a tiny but real physical push. In the frictionless vacuum of space, even this minuscule recoil from anisotropic or directionally biased thermal radiation could produce the exact constant acceleration the scientists were measuring. It was not a mysterious force from the cosmos, but the gentle nudge of the spacecraft's own warmth. This explanation fits the data well and is now considered the most likely solution. Yet a sliver of doubt remains for some. After all the complex modeling and painstaking calculations, a tiny residual anomaly might still linger, a fraction of the original effect that the heat theory cannot completely account for. This leaves a tantalizing, minuscule door open, a suggestion that perhaps there is still something new to be discovered in the quiet drift of our oldest interstellar travelers. Our own solar system holds its own share of impossible movements, but in 2017, a visitor from a completely different star system brought its own set of riddles. The Pan-STARRS telescope in Hawaii spotted a faint point of light moving at blistering speed, an object tracing a path so hyperbolic it could only have come from the void between the stars. It was named Oumuamua, Hawaiian for scout or messenger from the distant past. This was the first interstellar object ever detected passing through our neighborhood, and it was unlike anything we had ever seen. Its light curve, the pattern of how its brightness changed over time, revealed a shape so extreme it defied natural explanation. Oumuamua was tumbling through space, and its brightness varied by a factor of 10 as it spun. This could only mean one thing: it was profoundly elongated, a cosmic cigar perhaps 10 times longer than it was wide. No known asteroid or comet from our own solar system has such a shape. But the strangeness did not stop there. As it hurtled away from the Sun, something was giving it an extra push. Its trajectory showed a small but definite non-gravitational acceleration, a nudge that could not be explained by the gravity of the Sun or planets alone. For a normal comet, this is an easy puzzle to solve. Comets are icy, and as they approach the sun, they heat up and release jets of gas and dust. This outgassing acts like a natural rocket engine, altering the comet's path. The crucial clue, however, was what was missing. When astronomers pointed their most powerful telescopes at Oumuamua, they saw nothing. No surrounding cloud of gas, no dusty tail, no signature of water or carbon dioxide, no coma at all. It was as dark and featureless as a deep space rock. So what was pushing it? One camp argued it must be a comet after all, an exotic one releasing very pure hydrogen or other gases that our instruments could not detect. This hidden outgassing could provide the thrust without producing a visible coma. Others insisted it was an asteroid, a rare, porous rock that somehow accelerated without any apparent mechanism. The debate raged precisely because no single natural explanation cleanly fit all the data. The object's unusual shape, its lack of a tail, and its mysterious acceleration created a perfect storm of anomalies. This opened the door for a more radical proposal from Harvard astronomer Avi Loeb. He suggested that Oumuamua's properties were consistent with it being an artificial object, specifically a light sail. A light sail is a thin, reflective sheet that uses the pressure of sunlight for propulsion, much like a boat's sail uses wind. A large, thin sheet of material, perhaps a derelict piece of alien technology, would naturally be shaped like a pancake or a long blade. As it tumbled, its changing surface area would produce the dramatic light curve we observed, and the non-gravitational acceleration. That could be the gentle, constant pressure of sunlight itself pushing on this vast, thin sail. The scientific community largely remains skeptical, favoring natural origins, however exotic. Yet the core problem persists. Oumuamua is now too far away and too faint to ever be observed again. It has vanished back into the interstellar dark, taking its secrets with it. We were visited by a cosmic scout, and we are still arguing about what it was, a silent testament to the universe's capacity for wonder. Just as one mysterious visitor departed, another class of cosmic phenomenon demands our attention, not with a steady presence but with a sudden, violent shout. From the depths of space come blasts of raw energy so immense and so fleeting they defy belief. These are fast radio bursts, or FRB. In the span of a single millisecond, less time than it takes to blink, one of these bursts can release as much energy as our sun puts out over 80 years. They are cosmic gunshots heard across billions of light years, and then they are gone. When the first one was discovered in archived data in 2007, astronomers were so skeptical they spent years ruling out earthly sources, from microwave ovens to cell phone towers. But the signals were real, and they were coming from far beyond our galaxy. The mystery only deepens when you look at their behavior. Most FRBs are one-hit wonders, a single, brilliant flash that never repeats. This suggests a catastrophic, one-time event, the final death cry of a collapsing star, or the violent merger of two incredibly dense objects like neutron stars. But then there are the repeaters. One source, known as FRB 1211-2, has been firing off bursts for years, sometimes in frantic, repetitive clusters. This single observation shattered the simple cataclysm theory. Whatever is making these bursts can survive the event, meaning the source is not destroyed in the process. So what cosmic engine can produce such staggering power over and over again from the same spot? The current best guess points to magnetars. Imagine a neutron star, the collapsed core of a giant star, crushed into a sphere just a dozen miles across but weighing more than our sun. Now take that and give it a magnetic field 1,000 trillion times more powerful than Earth's. That is a magnetar. The stresses on its crust are unimaginable, capable of causing starquakes that could, in theory, unleash these titanic radio shrieks. Yet even this fantastic object may not be enough to explain the most energetic repeating bursts we see. Could something even more exotic be at work? Some scientists have speculated about phenomena involving evaporating black holes or immensely powerful jets of plasma from active galactic nuclei. The sheer distance these signals travel adds another layer of mystery. As an FRB races across the cosmos, it passes through diffuse clouds of ionized gas that slow it down, with higher frequencies arriving just a fraction of a second before the lower ones. This dispersion measure tells astronomers just how much material the signal has passed through, making FRBs incredible tools for mapping the otherwise invisible matter between galaxies. We are left with a paradox, using these mysterious signals to chart the cosmos while still having no firm idea what they truly are. They are brief, brilliant, and deeply enigmatic, a reminder that the universe is still capable of shouting surprises at us from the void. While the universe expands at an accelerating rate, our own galactic neighborhood is caught in a powerful local current. Our Milky Way, along with thousands of other galaxies, is racing through space at over 1,000,000 miles per hour, pulled by a force we cannot directly see. This is the mystery of the Great Attractor, a colossal gravitational anomaly located some 250 million light-years away in the direction of the constellation Centaurus. It acts like a cosmic drain, drawing us and our entire local supercluster of galaxies toward its unseen center. For decades, its true nature was hidden from view, lying directly behind the plane of our own Milky Way. This region is known to astronomers as the zone of avoidance. Imagine trying to see a distant city by looking straight through the dense smoke and bright lights of your own metropolis. That is the challenge we faced. The thick band of dust, gas, and countless stars in our galaxy's disk completely obscured our optical view, rendering the Great Attractor a ghost, a presence we could only infer from its immense gravitational tug. The breakthrough came with telescopes that see the universe in different kinds of light. By using X-ray observatories and infrared instruments, we could finally peer through the galactic clutter. These technologies revealed that the Great Attractor is not an empty point of immense gravity, but is in fact the core of the Laniakea supercluster, a vast filament of over 100,000 galaxies all bound together by their mutual gravity. This was a monumental discovery, finally giving a name and a form to the source of the pull. Yet the mystery did not end there. The sheer mass of all those galaxies, as enormous as it is, still does not seem to be enough. The motion of our galaxy and others suggests the pull is even stronger than the visible Laniakea supercluster can account for. This points to something even larger and more massive lurking in the darkness beyond, an immense structure of dark matter and unseen galaxies that is pulling on the Great Attractor itself. So the force that guides our cosmic journey may itself be guided by a shadow we have only just begun to sense, a hidden hand shaping the flow of galaxies on the grandest of scales. The same violent flashes that illuminate the cosmos also leave behind permanent scars, etched into the very fabric of the universe. Yet some of the most enduring mysteries are not written in light, but in stone, hidden in the very rocks we have brought back to Earth. The Apollo missions returned with more than just souvenirs. They carried evidence of a lunar past that should have been impossible. Samples of the moon's ancient crust revealed a startling secret. Billions of years ago, our airless, geologically quiet neighbor had a powerful magnetic field. This discovery sent shockwaves through planetary science because, according to every model we have, the moon should never have had one. A global magnetic field, like the one that protects Earth, is generated by a dynamo effect. This requires a liquid, electrically conductive core churning in a complex dance, driven by heat from within. The problem is the moon's size. It is simply too small. Its core should have cooled down and solidified relatively quickly after its formation, shutting off any planetary dynamo within 1 billion years or so. Yet the magnetic fingerprints locked in the lunar rocks tell a different story, one of a robust field that persisted for over 1 billion years longer than it had any right to. So what kept the moon's heart hot and stirring for so long? One compelling theory points to a dramatic external power source. In its youth, the solar system was a violent shooting gallery. The Moon's orbit may have been significantly different, and a series of massive asteroid impacts could have rocked the entire world. The tremendous energy from these collisions might have stirred the lunar core like a spoon in a cup of coffee, reheating it and giving the dynamo a temporary, powerful boost. Another idea suggests the Moon's dynamo worked differently from Earth's. Perhaps it was powered not by heat but by the slow crystallization of its core. As the liquid iron core gradually solidified, the lighter elements would be pushed out, driving a slow, persistent churning that could sustain a magnetic field for eons. While both of these theories are elegant, neither provides a perfect fit. The impact-stirring model struggles to explain the field's remarkable longevity, while the core crystallization theory may not account for its early strength. The data presents a frustrating puzzle where the pieces from different models almost fit, but not quite. This lunar mystery forces us to question the fundamentals of planetary magnetism itself. We thought we understood the basic recipe for a magnetic field, but the Moon is a stark reminder that other, unknown ingredients might be at work in the cosmic kitchen. It suggests that our models of how small, rocky worlds evolve are incomplete, and that a silent, cold satellite can hold the secrets to a surprisingly dynamic past. High above the cloud tops of Saturn, a storm of impossible geometry rages. Encircling the planet's north pole is a colossal hexagon, a six-sided jet stream so vast that our entire Earth could fit comfortably within its walls. This is not a fleeting atmospheric quirk. We have watched it persist for decades, a rotating geometric figure etched into the atmosphere of a gas giant, defying everything we know about how fluids behave on a spinning sphere. In our own experience, storms and weather systems are swirling ovals or formless vortices. Think of Jupiter's Great Red Spot or a hurricane on Earth. They are chaotic, organic shapes. The Saturn hexagon is different. Its six nearly perfectly straight sides are a stark, artificial-looking contrast to the natural chaos of a planetary atmosphere. It is a puzzle written in wind and cloud, a structure that should not be able to hold its form for so long. The mystery lies in its stability. How can a flowing, gaseous atmosphere lock itself into such a rigid, geometric pattern and maintain it through seasons and years? Scientists have turned to laboratory experiments to find answers. In tanks of spinning fluid, they can create similar polygonal shapes by carefully controlling the speed of the rotation and the differential flow of the liquid inside. These experiments show that under very specific conditions, a rotating fluid can indeed organize itself into shapes with 3, 4, 5, or 6 sides. But scaling this delicate laboratory phenomenon up to a planet the size of Saturn introduces staggering complexities. The sheer scale is one thing, but the endurance is another. The hexagon has been observed since the Voyager flybys in the 1980s, and it was still there when the Cassini mission ended its mission decades later. This is not a temporary pattern that forms and breaks apart. It is a permanent feature, a machine made of air that continues to run with flawless precision. The energy required to maintain those sharp corners against the dissipating forces of turbulence and friction is immense, and the exact mechanism that powers this planetary-scale engine remains just out of reach. We can create a tiny, temporary hexagon in a lab on Earth, but we cannot fully explain the mighty, enduring one on Saturn. It stands as a monumental lesson in humility, a reminder that the universe often prefers elegant, simple shapes, even in the heart of the most complex and violent storms. Far beyond the swirling storms of Saturn, a different kind of irregularity is stamped onto the deepest map of the universe. Etched into the ancient light from the dawn of time is a chilling blank spot, a cosmic cold that defies easy explanation. This is the cosmic microwave background cold spot, a colossal and mysterious region in the afterglow of the Big Bang. The cosmic microwave background, or CMB, is the oldest light we can see, a snapshot of the infant universe when it was just 380,000 years old. For the most part, this background glow is incredibly smooth, with only tiny, random variations in temperature, but the cold spot is different. It is a vast, circular patch of sky, significantly colder than its surroundings by about 70 microkelvins. While that sounds like a trivial difference on the scale of the entire CMB, it is a massive and statistically significant anomaly. It should not be there. So what could cause such a profound chill in the universe's first light? One leading theory points to a cosmic emptiness on a scale that is hard to fathom. This idea suggests the cold spot is a shadow cast by a supervoid, an immense region of space spanning over 1 billion light-years that contains far fewer galaxies and galaxy clusters than average. As light from the CMB travels through such a void, it loses energy while climbing out of the void's weaker gravitational field, a phenomenon known as the integrated Sachs-Wolf effect. This would make the light appear colder to us, creating the spot we see. It is a cosmic optical illusion, a shadow of nothingness. The problem is, when astronomers went looking for this proposed supervoid, the results were inconclusive. While some studies found underdense regions in the general direction of the cold spot, none were large enough or empty enough to fully account for the extreme temperature drop we observe. The shadow does not seem to have a source that matches its size. This failure has led to a far more radical proposal, one that ventures into the realm of speculative physics. Could the cold spot be a bruise from a collision with another universe? In the multiverse theory, our universe is just one bubble in a vast cosmic foam, with other bubble universes constantly inflating into existence. If our universe had a close encounter with another bubble in the distant past, the energy of that collision could have left a distinct imprint on the CMB, a cold spot exactly like the one we see. It is a breathtaking thought that we might be seeing direct evidence of a reality beyond our own. Yet this idea, while captivating, remains highly controversial and is far from proven. Neither the supervoid nor the multiverse collision provides a perfect, universally accepted answer. This leaves the cold spot as a persistent and profound thorn in the side of cosmology. It is a potential flaw in our standard model of the universe, a reminder that our most fundamental maps of reality might still be missing a crucial and deeply strange piece of the puzzle. Dark matter is the ghost in the cosmic machine, the unseen hand that shapes every galaxy we see. But what happens when we find a galaxy that appears to have no ghost at all? That is the stunning reality of NGC 1052DF2, a strange, diffuse galaxy that seems to be missing its dark matter. This discovery sent a shockwave through astronomy because it directly contradicts the foundational rule that galaxies cannot form or hold themselves together without this invisible scaffold. The evidence comes from the measured motions of the galaxy's own star clusters. Astronomers calculated how fast 10 bright globular clusters were orbiting the galaxy's center. The speed of these orbits reveals the total mass, the gravitational pull holding everything together. The result was baffling. The speeds were exactly what you would expect if only the visible stars were there, their collective gravity perfectly accounting for the motion. There was no extra pull, no sign of the immense hidden mass that defines every other galaxy of its size. It is like watching a carousel spin, where the horses are moving at a speed that perfectly matches the strength of the visible motor, with no hidden engine providing an extra mysterious push. This galaxy is running on the gravity of what you see and nothing more. The implications are profound. If dark matter is truly absent, it means galaxies can form through a process we do not yet understand, one that does not require a dark matter halo to seed their birth. It challenges the very narrative of how structure emerges in the universe. Naturally, such a radical claim sparked intense debate, and the entire case hinges on one critical number: the galaxy's distance from us. If NGC 1052DF2 is closer than initially thought, its stars would be intrinsically dimmer, meaning there is less visible mass present. With less visible mass, you would need a larger amount of dark matter to explain the observed motions of the clusters. The controversy erupted when a separate team of astronomers argued for a much closer distance, which would reintroduce the need for dark matter and make the galaxy ordinary. However, more recent and precise measurements from the Hubble Space Telescope have strongly reaffirmed the original, larger distance. This confirmation solidifies the anomaly. The stars are indeed as bright and massive as first estimated, and their gravity alone is sufficient. The mystery, therefore, deepens. How did this galaxy lose its dark matter, or was it never there to begin with? One compelling theory suggests a violent past. Perhaps this diffuse galaxy was once a satellite of a much larger galaxy, and in an ancient, catastrophic encounter, the surrounding dark matter was brutally stripped away, leaving behind the bare bones of the visible stars. This would be a cosmic ghost, a galaxy stripped of its soul. Yet, if this is the case, the process must be incredibly fine-tuned to remove all the dark matter without also tearing the visible stars apart. The existence of NGC 1052DF2 forces us to confront an uncomfortable possibility. Our standard model of cosmology is brilliantly successful, but it might not be the only way the universe builds a galaxy. This single, ghostless galaxy stands as a monumental outlier, a cosmic rebel that proves the universe still has a few fundamental rules left for us to write. High above the frozen plains of Antarctica, a balloon-borne experiment was listening for whispers from the cosmos. The Antarctic Impulsive Transient Antenna, or ANITA, was designed to catch the faint radio pulses generated when ultra-high-energy particles from space interact with the Antarctic ice. During its flights in 2006 and 2014, it detected something that should not exist. The experiment picked up signals of two high-energy tau neutrinos, but they carried an impossible origin story. These particles seemed to be coming upward from the direction of the star Antares, having traveled straight through the entire planet Earth. This single observation defies everything we know about how neutrinos behave. Neutrinos are famously ghostly particles, so elusive that trillions pass through your body every second without a single interaction. But at the extreme energies ANITA detected, that changes. A neutrino with that much power should not be able to slip through the Earth unnoticed. It should crash into the dense matter of our planet's core, annihilating instantly in a shower of other particles. It is the difference between a gentle breeze passing through a screen door and a cannonball trying to do the same. The cannonball will always hit the door and explode. Yet ANITA appeared to have detected two cannonballs that passed through unscathed. To explain this, physicists had to venture into the wildest frontiers of theoretical physics. One proposal involves a hypothetical particle known as a sterile neutrino. Unlike the three known types of neutrinos that interact through both gravity and the weak nuclear force, a sterile neutrino would feel only gravity, making it even more ghost-like and capable of passing through any barrier. Another, even more exotic idea points to something called unparticle physics. This speculative theory suggests there exists a hidden sector of reality, a shadow universe with different rules and particles that do not have a definite mass. These unparticles could theoretically interact with regular matter in ways that make it seem like a high-energy neutrino is traveling through the Earth when something else entirely is at work. It is a concept that challenges our very definition of what a particle is. Despite the thrilling possibilities, the mystery of the ANITA anomalous events remains unresolved. Follow-up experiments, most notably the powerful Ice Cube Neutrino Observatory buried deep in the same Antarctic ice, have not seen a confirming signal. Ice Cube should have detected dozens of such upward-going events if they were real, but its data shows nothing out of the ordinary. This leaves the ANITA detections in a scientific limbo. They could be a statistical fluke, an unexplained background noise, or perhaps a sign of an entirely new physical process so rare that our current tools have only glimpsed its shadow. They are a tantalizing, unconfirmed hint that the rules of the game might be even stranger than we have dared to imagine. From the Antarctic ice to the depths of space, nature continues to defy our expectations with forms of breathtaking precision. Suspended in the constellation Monoceros, a cosmic structure glows with an almost unnatural symmetry. This is the Red Rectangle Nebula, a celestial artwork surrounding the binary star HD 44179. Through the telescope, it does not look like a typical, chaotic cloud of gas. Instead, it presents a series of perfect concentric rectangles, like a set of glowing red ladders stacked within one another, connected by vivid rungs. It is a geometric dream, a vision of order etched against the randomness of the cosmos. The heart of this phenomenon is a pair of aging stars locked in a tight orbital dance. As these stars evolve, they are shedding their outer layers in a continuous, gentle outflow. We understand the basic mechanism, the stellar winds, and the dense disk of dust that surrounds the binary pair. This disk acts like a nozzle, funneling the ejected gas into two opposing cones that stream out from the star system, above and below the disk. From our vantage point, we are looking directly at the side of this double cone structure. The edges of these cones appear as the two long sides of the X, and the ladder rungs we see are actually the result of episodic outbursts from the stars. Imagine squeezing a tube of toothpaste in a series of short, even pulses, creating a stack of rings that expand outward. That is similar to what is happening here, with bursts of material creating the distinct, evenly spaced rungs. Yet, this elegant analogy only gets us so far. The profound mystery is the perfection of the geometry. Why are the shapes so sharply rectangular and symmetrical? The physics of fluid dynamics and stellar winds should create much more turbulent, curved, and irregular structures. The forces involved are chaotic, but the result is a figure of stunning precision. The precise conditions that allow these cones to maintain their straight-line edges and form such a perfect X shape are not fully captured in our computer simulations. It challenges our models of how planetary nebulae form and evolve in their earliest stages, suggesting there are stabilizing factors or intricate interactions between the stars and their surrounding disk that we have not yet accounted for. The Red Rectangle Nebula is a beautiful paradox, a naturally occurring structure that looks entirely designed. It stands as a powerful reminder that the universe has a hidden affinity for order, capable of painting perfect shapes with the brush of chaos. The geometric perfection of the Red Rectangle Nebula shows a universe capable of stunning order, but what happens when we find a region of space defined by its profound lack of structure? Drifting through the constellation of Bootes lies a cosmic desert of almost unimaginable scale. This is the Bootes Void, a spherical region of space so vast it could swallow thousands of galaxies like our own, yet it holds almost none. Stretching for about 330 million light-years across, this great nothing is not a perfect vacuum, but its emptiness is staggering. Where a typical slice of the universe would be filled with thousands of bright galaxies, the Bootes Void contains only a few dozen, scattered like lonely islands in an endless, dark sea. The sheer scale of this emptiness is what defies explanation. According to our standard models of cosmic evolution, the universe's large-scale structure is a cosmic web, a filamentary network of galaxy clusters and superclusters woven together with immense dark matter strands. The voids between these strands are expected, but they should be relatively small. The Bootes Void is a yawning chasm in that web, a hole so gigantic it seems to challenge the very idea of a uniform cosmos. How could such a colossal nothingness come to be? One theory suggests it is the result of a cosmic merger, where many smaller voids over billions of years gradually coalesced, their emptiness flowing together to create one supervoid. Another, more unsettling possibility is that we are simply looking at a statistical fluke. a one-in-a-million underdense region that just happened to form in our observable backyard. Yet its size makes this incredibly unlikely. The void forces us to confront the limits of our understanding. Could there be an unknown physical process, a mechanism that actively suppresses galaxy formation on scales we thought were impossible? Or does the Boots void hint that the universe is far more lumpy and irregular on the grandest scales than our cherished cosmological principle allows? This great emptiness is a silent question, a hollow in the cosmos that echoes with our own lack of knowledge. The thin, rust-colored air of Mars holds a secret, one that comes and goes like a ghost. Our robotic explorers on the surface, like the Curiosity rover, have repeatedly sniffed out tiny, tantalizing whiffs of methane gas. This should not be happening. The Martian atmosphere is a harsh place, bathed in ultraviolet radiation from the sun that acts like a cosmic cleaning agent, breaking methane molecules apart in just a few hundred years. Any methane we detect today cannot be an ancient leftover. It must be coming from a source that is active right now, releasing the gas in the present day. This turns a simple chemical detection into a profound question. What is producing methane on Mars today? The possible answers split into two thrilling paths. The first is geological. A process called serpentinization occurs when certain rocks, like olivine, react with water deep underground. This chemical reaction can produce methane as a byproduct. If Mars has liquid water reservoirs interacting with its crust, it could be constantly but sporadically venting the gas. The other possibility, the one that truly captures the imagination, is biological. On Earth, the vast majority of atmospheric methane is produced by living organisms, from microbes to livestock. Could the same be true on Mars? Is a hidden, subsurface biosphere of Martian microbes respiring and releasing this gas? The plot thickens with the data itself, which is frustratingly inconsistent. Curiosity has seen the methane levels spike dramatically on some days, only to drop back to undetectable levels on others. Even more puzzling, the ExoMars Trace Gas Orbiter, a sophisticated European spacecraft circling the planet, has largely failed to confirm these large surface bursts from high above. This contradiction is the heart of the mystery. Are the rovers detecting localized, short-lived plumes that dissipate before an orbiter can see them? Is something at the rover site itself, perhaps the ancient soil releasing trapped gas when disturbed, creating a false signal? Or is the methane being destroyed by some unknown chemical process in the lower atmosphere before it can rise and spread? Each new reading deepens the puzzle rather than solving it. We are left with a planetary-scale detective story, chasing a spectral signature that could be the key to understanding whether Mars is a geologically active world, a formerly inhabited one, or perhaps just maybe a world that is still alive. The mystery of Tabby's star only deepened with time, refusing to surrender its secrets easily. As astronomers trained new instruments on that distant sun, a crucial clue emerged from the Spitzer Space Telescope. Its infrared eyes revealed something startling. The star's bizarre dimming was not uniform across all colors of light. It was wavelength dependent, meaning the dimming was more pronounced in some wavelengths than others. This single observation delivered a devastating blow to the solid megastructure hypothesis. An opaque, solid object like a Dyson Spheres panel would block all light equally, creating a shadow that was the same depth across the entire spectrum. The new data proved this was not the case. The dimming pattern pointed decisively toward something made of tiny, fine particles, dust. The leading theory now suggests we are witnessing immense, uneven clouds of cosmic dust orbiting the star. But this answer simply replaces one enigma with another. What is the origin of this dust, and why does it behave in such a bizarre, clumpy, and asymmetric fashion? Normal circumstellar dust, the kind left over from planet formation, should be distributed in a smooth, thin disk and would have been blown away by stellar radiation long ago. The dust at Tabby's star is something else entirely. It must be constantly replenished, perhaps from the grinding collision of moons or the slow disintegration of a giant comet swarm on a wildly eccentric orbit. Yet even these scenarios struggle to explain the sheer scale and the erratic, deep-dimming events we observe. So while the idea of a solid alien megastructure has been ruled out, the fundamental weirdness remains. We are left with a star being occulted by dust clouds of unknown origin, a natural phenomenon that somehow mimics the irregularity of an artificial construction. The ghost of the alien megastructure idea lives on, not as a likely explanation, but as a haunting reminder of how much we still have to learn. Even the universe's first light holds a strange and unsettling alignment, a pattern that seems to look back at us. Etched into the cosmic microwave background, the ancient afterglow of the Big Bang itself is a mysterious and controversial feature known as the axis of evil. This is not a single spot or a void, but a curious directional alignment. The hot and cold spots in this primordial radiation appear to be correlated with the plane of our own solar system and the direction of our sun's motion through the galaxy. At first, this might sound like a minor curiosity, but for cosmologists, it is deeply troubling. The CMB is a snapshot of the universe when it was only 380,000 years old, a picture of a time long before galaxies, stars, or our solar system even existed. This infant universe should be entirely uncorrelated with the much later, local structure we find ourselves in today. It would be like finding a fossilized dinosaur bone that had your own family crest carved into it, a bizarre connection across billions of years that simply should not be. So what could possibly explain this eerie alignment? The most conservative answer is that it is a statistical fluke. When you look at any large set of data, random patterns can sometimes appear to form a significant structure purely by chance. Scientists have run countless simulations, and while the axis of evil appears to be a fairly unlikely coincidence, it is not completely impossible. Another strong possibility is that this is not a feature of the universe at all, but a systematic error in how we process the data from our telescopes. To see the faint whisper of the CMB, we first have to subtract the brilliant foreground glow of our own Milky Way galaxy. If our models for this subtraction are even slightly imperfect, they could leave behind a false signal that just happens to align with our solar system's orientation. Yet, despite years of effort, no one has been able to definitively prove that such an error is the source. This leaves the most radical and unsettling possibility of all, that the alignment is real. If that is true, it directly challenges the cosmological principle, one of the most fundamental assumptions in all of science. This principle states that the universe is homogeneous and isotropic, meaning it looks roughly the same in every direction and from every location. There is no central point, no special place, no cosmic axis. The axis of evil, if genuine, suggests that our place in the cosmos might not be so random after all. It hints that we might be living in a universe with a preferred direction, a fundamental lopsidedness written into its earliest moments. Is it a ghost in the data, a flaw in our methods, or a crack in the foundation of modern cosmology? This controversial axis remains a profound puzzle, a whisper from the dawn of time that seems to know we are here. A supermassive black hole is racing across the cosmos, a cosmic fugitive fleeing the scene of a cataclysm. Astronomers have spotted a behemoth with a mass equivalent to 20 million suns, hurtling away from its host galaxy at incredible speed. But this is no clean escape. It is leaving a brilliant, incriminating trail behind. Stretching for over 200,000 light-years, twice the diameter of our Milky Way, is a narrow corridor of young, blue stars. It is as if this monstrous engine of destruction is, against all odds, sowing the seeds of new life in its chaotic wake. The black hole is moving so fast it could travel from Earth to the Moon in just 14 minutes. This is not a random journey. It appears to be the direct result of an unimaginably violent event, a gravitational wave kick. The theory goes like this: when two supermassive black holes in a galactic core finally spiral inward and merge, the event is not perfectly symmetrical. The newly formed black hole can recoil, blasted away by the intense, directional torrent of gravitational waves rippling out from the collision. Think of it like the kick from a rifle, where the energy of the blast propels the gun backward. In this case, the rifle is the merged black hole, and the bullets are the ripples in spacetime itself. If the kick is powerful enough, it can overcome the immense gravitational pull of the galaxy's core and eject the black hole entirely. While physicists had predicted this phenomenon, actually observing it was a stunning surprise. The discovery provides the first tangible evidence for this specific type of recoil, a crucial piece in the puzzle of how black holes grow and interact. Yet for every question it answers, a dozen more bloom. How common are these runaway behemoths? Is this a rare cosmic spectacle, or are the voids between galaxies secretly populated by these dark, lonely exiles? And what becomes of the galaxy left behind? Its central gravitational anchor is gone, potentially disrupting the orbits of billions of stars and throwing the entire system into a long, slow dance of instability. The universe has revealed a new kind of monster, one born from collision and set adrift, painting a line of stellar birth with the brush of its own violent escape. A black hole's feast is supposed to be a single, catastrophic meal. When a star wanders too close, the immense gravity stretches and tears it apart in a tidal disruption event, a spectacular flare of light as the star's own gas is shredded into a swirling accretion disk and consumed. These cosmic fireworks are, by their very nature, a one-time show. The star is destroyed completely, its debris falling inward to be devoured over months or years, fading steadily into darkness. But one particular event, catalogued as at 2018 HYZ, broke all the rules. It flared up in 2018 as expected, a star being ripped apart by a black hole, and then it faded away as if the cosmic curtains had closed. Astronomers had moved on. Then, years later, in 2022, something impossible happened. The corpse of the event suddenly roared back to life, not in visible light, but in a brilliant and unexpected surge of radio waves. It was as if a long-dead fire had spontaneously burst into a new, different kind of flame all on its own. This was unprecedented. A tidal disruption event is not supposed to have an encore. So what could possibly explain this delayed and energetic second act? One theory suggests a delayed jet. Perhaps when the star was first torn apart, the black hole launched a jet of relativistic particles, but it was initially pointed away from our line of sight, buried within the thickest part of the debris. Only years later, as the surrounding material thinned, could this powerful jet finally punch through and become visible to our telescopes as a bright radio source. Another, even more dramatic idea proposes a second course for the black hole's dinner. Maybe the initial TD was not a solitary event. The black hole could have encountered a previously unseen binary companion to the first star, a second star orbiting its doomed partner. The disruption of the first star might have destabilized the second's orbit, sending it spiraling in for its own destruction years after the first cataclysm. This would be a double helping of stellar material, creating a new outburst long after everyone thought the feast was over. Both theories push the boundaries of our models, forcing us to reconsider the chaotic environment around supermassive black holes. The reawakening of a 2018 HYZ challenges the very definition of a one-time event, revealing that even in the most violent processes, the universe might still have a few surprises waiting in the wings. This dark flow is not a gentle drift, but a powerful, coordinated current pulling entire clusters of galaxies in a single, specific direction. It is as if a cosmic wind is blowing through the universe, guiding the motion of the largest structures we can see. The evidence comes from studying the subtle motions of thousands of galaxy clusters. After accounting for the relentless expansion of the universe driven by dark energy, astronomers found a leftover velocity, a persistent flow that should not exist. These clusters are all moving coherently, pulled toward a point in the distant sky far beyond the edge of our observable universe. The gravitational pull of every known galaxy, star, and speck of dark matter we have mapped cannot explain this motion. The source of this immense tug lies somewhere in the unseeable void. So what could possibly be exerting such a force from beyond our cosmic horizon? One of the most breathtaking possibilities is that we are feeling the gravitational influence of another universe. In the multiverse theory, our universe is one bubble in a vast cosmic foam, with other bubbles constantly inflating into existence. The dark flow could be the gravitational tug from a massive structure in a neighboring universe, a phantom presence from a reality we can never directly observe. Another, equally radical idea suggests that this flow is a relic from the time before the Big Bang, an imprint from a previous cosmic era whose structures still exert a ghostly influence on our own. The scientific community remains deeply divided. Many astronomers attribute the dark flow to unaccounted for measurement uncertainties or subtle biases in how we observe the cosmic microwave background, which is used as a reference frame for these motions. They argue that such a profound claim requires irrefutable evidence which has so far remained elusive. Yet, the signal has persisted through multiple analyses, a stubborn outlier that refuses to be fully explained away. It stands as a provocative and unsettling hint, a potential crack in the foundation of our cosmic isolation, suggesting that the greatest structures in existence might be answering a call from a place we cannot go. The James Webb Space Telescope peered deeper into the cosmic dawn than ever before, and what it found has shaken the foundations of cosmology. These first images of the universe in its infancy revealed a collection of galaxies that should not exist. They are too massive, too bright, and far too mature to have formed in the mere few hundred million years after the Big Bang. They appear fully formed, like finding a thriving metropolis in a landscape that should only contain scattered, primitive villages. These so-called universe breakers are a direct challenge to our most fundamental models of how cosmic structure evolves. According to the standard timeline, the early universe was a dark age, filled only with hydrogen and helium gas and the invisible scaffolding of dark matter. Tiny fluctuations in this dark matter should have slowly, over hundreds of millions of years, drawn in that gas, eventually creating the first stars and the first small, faint protogalaxies. The galaxy's JWST sees leapfrog over this entire gradual process. They are not infants, they are cosmic teenagers already bulked up with the mass of billions of stars. How could they have assembled so much material and formed so many stars in a fraction of the time our models allow? The tension is profound. Either our understanding of the dark matter halos that seed galaxy formation is fundamentally wrong, or something was supercharging star formation in the early universe in a way we have never imagined. Some theorists are exploring exotic forms of dark matter that could have clumped together faster, jump-starting structure. Others suggest that the first stars were simply far more efficient, forming in colossal, explosive bursts that flooded these early galaxies with light. Yet every proposed solution creates new problems, forcing physicists to rewrite chapters of cosmic history we thought were settled. These impossible galaxies are not just outliers, they are a direct confrontation with our story of the universe's youth, a story we now realize we may have only just begun to read. Deep beneath the Antarctic ice, a different kind of observatory hunts for phantoms. The Ice Cube Neutrino Observatory is not a telescope of glass and mirrors, but a cubic kilometer of pristine ice, threaded with thousands of sensitive light detectors. Its quarry is the neutrino, the same ghostly particle that Anita studied, but IceCube seeks to pin them down to trace their paths back to a cosmic source. In a monumental breakthrough, it succeeded. For the first time, scientists identified the origin of a single, high-energy neutrino that had slammed into the ice. Its path led back to a blazing monster 4 billion light-years away, a blazar known as TXS 0506 plus 056. A blazar is a specific type of galaxy, one whose core houses a ravenous supermassive black hole. What makes it special is its orientation. This black hole is firing a jet of radiation and particles directly at Earth, a relentless cosmic blowtorch aimed straight at us. The detection was a triumph, finally linking these elusive particles to one of the universe's most powerful engines. But this solved mystery immediately revealed a deeper one. The correlation is not perfect. For every neutrino we can trace back to a brilliant blazar, there are countless others that arrive from seemingly empty patches of sky. These orphan particles carry immense energy, but they point to no visible cataclysm, no brilliant jet or exploding star. They are cosmic bullets fired from a hidden gun. This forces a difficult question. Are we missing a whole population of blazars whose jets are not pointed at us, making them appear dim and unrecognizable in our telescopes? Or are there other, even more exotic cosmic accelerators at work? Perhaps the mergers of neutron stars, long after their initial flash of gravitational waves, continue to belch out these high-energy ghosts. Maybe the turbulent regions around supermassive black holes, even in quiet galaxies, can occasionally hurl out a neutrino with unimaginable force. The very success of tracing one neutrino has exposed a vast landscape of ignorance. We now know that blazars can produce them, but we do not know if they are the primary source, or just one contributor to a deafening cosmic chatter we are only beginning to hear. These silent, phantom particles are messengers from the most violent corners of reality, and most of them are still refusing to tell us where they came from. Deep within the constellation of Cancer, a world orbits its sun in a blistering 18-hour year. This is 55 Cancri E, a super-Earth whose very composition reads like a cosmic fairy tale. Scientists believe this planet, twice Earth's size and 8 times its mass, could be a colossal diamond, a glittering jewel adrift in the void. The conditions there are a vision of hellish beauty. Tidal forces from its parent star have likely locked one face in perpetual daylight, creating a global lava ocean on its sunward side, while the interior is crushed under pressures that could forge carbon into a crystalline structure spanning thousands of miles. We are not looking at a planet with diamond mines, but a planet that is, in its very essence, a single massive gem. This incredible possibility arises from its inferred composition. Spectroscopic studies suggest the planet is overwhelmingly rich in carbon. Under the intense heat and crushing pressure inside 55 Cancri E, that carbon would be compressed into diamond, creating a geological wonder on a scale we can scarcely comprehend. Yet this magnificent vision creates a profound scientific puzzle. How does a planet made almost entirely of carbon form in the first place? Our own solar system provides the standard blueprint. Rocky planets like Earth are oxygen-rich, built from silicates and metal oxides. We are essentially made of sand and rust. This makes sense because our Sun has more oxygen than carbon. But the star 55 Cancri has a perfectly normal carbon-to-oxygen ratio, just like our own. According to every model of planetary formation, the planets that coalesce around it should be oxygen-rich worlds, not carbon kingdoms. So where did all the carbon come from? One theory proposes a violent, ancient theft. Perhaps 55 Cancri E was not born in its current orbit, but formed much farther out in the system, in the cold outskirts where carbon-rich ices could survive. A gravitational dance with a giant planet could have then hurled this embryonic world inward, into the scorching embrace of its star. Another, more radical idea suggests the entire system was once seeded by a cloud of material from a carbon-rich star that went supernova long ago, imprinting its unique chemistry on this entire pocket of the galaxy. The existence of this diamond world defies the standard recipe for making a planet, forcing us to consider that the cosmos has more exotic ways of building worlds than we ever dreamed. It is a place of impossible luxury and equally impossible origins, a glittering enigma that challenges our very understanding of planetary birth. Even the frozen wanderers of our solar system can hold a voice. When the European Space Agency's Rosetta spacecraft finally reached Comet 67P Churyumov-Gerasimenko after a 10-year journey, it discovered the comet was singing. Its instruments picked up a curious signal, a series of oscillations in the magnetic field surrounding the comet's nucleus. This was not a sound you could hear with human ears, as it vibrated at an incredibly low frequency of just 40 to 50 millihertz. But when scientists sped up the data, they heard a haunting, rhythmic melody, a series of clicks and pops that echoed through the void. This song was a complete shock. Comets are essentially dirty snowballs, colossal chunks of ice and rock, and they were not thought to possess any significant global magnetic field of their own. They lack the internal dynamo that powers the magnetic fields of planets like Earth. So what was creating this strange, structured chorus? The leading theory points to a complex dance between the comet and the solar wind. As the comet approaches the Sun, its ice heats up, releasing vast clouds of neutral gas and dust into space, creating its glowing coma. When the charged particles of the solar wind slam into this neutral cloud, the interaction can become extraordinarily complex. The solar wind particles can pick up electrical charge from the neutral comet material, creating new ions right at the boundary. This process might excite the comet's weak magnetic field, making it oscillate in a specific rhythmic pattern. It is a bit like the wind whistling through a narrow canyon where the shape and flow create a specific resonant tone. Yet, while this explains the general possibility of magnetic noise, it does not fully account for the precise, structured song that Rosetta recorded. The exact physical mechanism that transforms this chaotic interaction into such a clear and persistent rhythm remains one of the mission's most charming and enduring puzzles. We sent a robotic ambassador to a distant ice ball and found it humming a quiet, mysterious tune, a gentle reminder that even the smallest, coldest bodies in the cosmos can hold a beautiful surprise. But even the ghostly whispers from comets cannot prepare us for the sheer scale of the next anomaly. Stretching across an almost unimaginable 4 billion light-years, astronomers have mapped a structure so vast it seems to defy the very rules of the cosmos. This is the huge Large Quasar Group, a colossal alignment of brilliant galactic cores that forms a thread across the void. Quasars are the intensely bright hearts of distant galaxies, powered by supermassive black holes devouring colossal amounts of material. While they can cluster, finding them linked together in a coordinated group of this magnitude should be statistically impossible. The cosmological principle, a cornerstone of modern science, states that on the largest scales, the universe should look roughly the same in every direction. Matter should be evenly sprinkled like raisins in a vast, expanding loaf of bread. This principle assures us there is no special place, no center, and certainly no single structure that dominates the cosmic landscape. The existence of this quasar group throws that foundational idea into question. It is a cosmic skeleton, a filament of unimaginable size that should not exist if the universe is truly smooth and homogeneous at its grandest level. The probability of such a structure forming by pure chance is astronomically low, akin to randomly rolling a pair of dice and getting snake eyes 1,000 times in a row. So what does its presence mean? One possibility is that our understanding of the universe's initial conditions is flawed. The seeds for all cosmic structure were planted in the first fractions of a second after the Big Bang, during a period of hyper-expansion called inflation. Perhaps inflation did not smooth everything out as perfectly as we thought, leaving behind imprints that grew into these colossal, rare formations. Another, more unsettling idea is that we are seeing the shadow of a pre-Big Bang era, a relic from a time before our universe began, whose faint geometry is still etched onto the cosmos. This immense alignment is more than just a record-breaking curiosity. It is a direct challenge, a structure so large it forces us to reconsider the universe's fundamental architecture and question whether we truly understand the blueprint from which everything was built. Hovering in the darkness above our world is a story that refuses to die. The legend of the Black Knight satellite tells of an ancient, alien object orbiting Earth, a silent sentinel left by a long-vanished civilization. Its origins are as tangled as its fictional history, beginning not in space but with a genius on the ground. In 1899, Nikola Tesla was experimenting with his high-voltage apparatus in Colorado Springs when he detected strange, rhythmic radio signals. He boldly speculated they might be an attempt at communication from another world, perhaps Mars. Decades later, in 1960, a Time magazine article reported that the US Navy had detected a mysterious dark object in orbit, something they could not immediately identify. These two unrelated events slowly fused in the public imagination, creating the core myth of a non-human satellite watching us from the void. The mystery seemed to be confirmed for many when grainy, declassified photographs appeared to show a strange, long-lost object floating near the space shuttle. The legend was complete, an alien artifact thousands of years old circling our planet. The reality, however, is far more mundane, yet in its own way revealing. That iconic space shuttle photograph almost certainly shows a thermal blanket that had been accidentally lost during a spacewalk, a piece of insulating material tumbling end over end in the sunlight. The dark object tracked by the Navy was likely the remains of a Discoverer satellite, its discarded corona capsule or other debris from the early space race. We are surrounded by a cloud of human-made clutter, a graveyard of spent rocket stages, dead satellites, and lost tools, all mistaken for something far more profound. So why does the Black Knight story persist with such power? It taps into a deep and fundamental human yearning, the desire to know we are not alone. In the random signals, the forgotten debris, and the grainy photos, we see what we want to see, a sign that someone is out there, that we are part of a larger cosmic community. The true mystery is not in the orbit but in our own minds, a testament to our endless capacity for wonder, turning a piece of lost insulation into a ghost from the stars. The silent acceleration of Oumuamua remains its most confounding feature. To explain its movement, scientists proposed a hidden outgassing mechanism. Imagine a cosmic iceberg warmed by the sun, releasing trapped gas from its surface in faint, invisible jets. This steady stream of molecules shooting away into space would act like a miniature rocket engine, giving the object a gentle, continuous push. The leading candidate for this propellant was pure molecular hydrogen. Because hydrogen is difficult to detect from Earth, its release could theoretically provide the necessary thrust without creating a visible, dusty coma. Yet this elegant solution crumbles under closer scrutiny. For Oumuamua to have accelerated as much as it did, it would have needed to vent a colossal amount of material, potentially losing over 10% of its total mass. An expulsion of that magnitude would have dramatically altered the object's rotation, sending it into a wild, unpredictable tumble. Our observations, however, showed a stable spin. Furthermore, the heat from the sun required to sublimate that much hydrogen from its surface would have been insufficient at the distance Oumuamua was traveling. The outgassing theory demands a substance that can explain both the push and the pristine silence, a gas that leaves no trace and exerts no torque, a set of conditions no known comet perfectly fulfills. While most astronomers firmly believe a natural, if exotic, explanation exists, the precise physics behind that mysterious nudge remains frustratingly just out of reach, a ghostly hand that pushed our first interstellar visitor on its way. Even the very first moments of creation hold a stubborn accounting error. In the blistering heat of the Big Bang's first few minutes, a process known as Big Bang nucleosynthesis forged the universe's original elements. The models for this cosmic alchemy are breathtakingly precise, accurately predicting the amounts of hydrogen and helium we see across the cosmos. But for the third lightest element, lithium, the math falls apart. Our theories insist the infant universe should have left behind a specific, measurable quantity of lithium-7, the element's most common isotope. Yet when we look at the atmospheres of the most ancient stars in our galaxy, stars that formed from that primordial material, we see only about 1/3 to 1/2 of the expected amount. A vast quantity of the universe's original lithium has simply vanished. This is the cosmological lithium problem, a glaring deficit that has persisted for decades. Where did it all go? One line of investigation suggests our understanding of nuclear physics in that extreme environment is incomplete. Perhaps unknown reactions occurred between those newly formed nuclei, gobbling up lithium faster than our equations can account for. Another possibility points the finger at the stars themselves. These ancient stellar furnaces might have internal processes that destroy lithium, effectively burning it away over their long lifetimes and masking the true primordial abundance. Yet, even the most sophisticated models of stellar physics struggle to explain the scale of the discrepancy. Every proposed solution seems to create new problems, leaving the lithium shortfall intact. This persistent mismatch is more than a minor oversight. It is a direct challenge to the standard model of cosmology. It suggests that our detailed picture of the universe's first moments, a story we thought we had written in stone, might contain a fundamental flaw. The missing lithium is a ghost from the dawn of time, a whisper that the recipe for the cosmos may have included an ingredient we have not yet discovered. From the phantom push on our pioneer probes to the universe-spanning force of dark energy, we have crossed a landscape of cosmic riddles. We have listened for a signal that never repeated, chased a visitor from another star, and stared into the chilling blank spot of a cold void. These are not failures of science, but its greatest triumphs. Each mystery is a frontier, a place where our maps end and true discovery begins. They remind us that curiosity is our most powerful instrument, and that every answered question simply reveals a deeper, more fascinating layer of the unknown. So the next time you find yourself under a clear night sky, look up. Remember the silent hexagon on Saturn, the singing comet, and the diamond world glittering in the deep. Let that sense of wonder fill you, because the universe is not just stranger than we imagine, it is stranger than we can imagine. The greatest mysteries are still waiting. If you enjoyed this journey through the cosmos's greatest unsolved case files, please show your support by liking this video and subscribing for more explorations into the unknown. And we would love to hear from you. What single space mystery makes you question everything? Share your thoughts in the comments below.